Greetings and salutations, good people. This video is on the chain rule. It's a continuation of what we discussed in our classroom. This really uses the open stax calculus book in retrospect to the Newton Alta adaptive learning system. So let's jump right on into it. We talked about the chain rule is a composition of, or taking the derivative of the composition of two functions, meaning that if we have f of g of x, which is, a fog, then we would take the derivative of f times our g, and then we would multiply by the derivative of g. So if I do a quick example of what I mean by that is, let's say h of x equals to, I don't know, 5x squared, right? Plus 10x, or just 10 rather, to the third power. So if we wanted to find the derivative using the chain rule, or aka the power rule, depending on what book you have, we would bring the 3 to the front, right? And so that would be 3 times 5x squared plus 10. And then we would subtract that by 1, which would just give us squared. Then we also would need to take the derivative of what's on the inside. So the derivative of 5x squared plus 10 will be times a 5, not 5, times a 10x. All right. Now, to make it look nice and pretty and simplistic all together, we will multiply this 3 times this 10, and we would do a 30x times 5x squared plus 10 to the second power. So that will be my derivative. Again, we took the derivative of f, and then we took the derivative of the g in this inside, and we multiplied the two together. But this video is on the more complicated problems that we possibly would see in our homework assignments. So if I look at, let's look at our next example, which would be, it says h of t equals to a negative 8x divided by the square root of 9x cubed plus 10. All right, now we can do this as the quotient rule, or we could look at it as possibly negative 8x times 9x cubed plus 10 to the negative 1/2. Remember, anytime we have a square root of something, that is x to the 1/2. Anytime we have a fraction or exponent in our denominator, we can look at it as x to the negative power of whatever our exponent is. So we can look at it both of those ways. So again, I'm just going to use this approach versus using the quotient rule. All right. So if I'm looking at this, this is 8x or negative 8x times this 9x cubed plus 10 to the negative 1/2. This means I would need to use the product rule. So again, what is that product rule? The product rule is the derivative of the first times the second plus the derivative of the second times the first. So the first is your f and the second is your g. So let's look at the derivative of f, right? So what is the derivative of negative 8x? Well, I would tell you it's just simply negative 8. Then we need to multiply it by g. What is my g here? My g is this 9x cubed plus 10, right, to the negative 1/2. All right, that's just my g. Now I need to look at what is the derivative plus what is the derivative of g. Well, let's look at it. I need to bring the 1/2 to the front, so that'll be a negative 1/2 times 9x cubed plus 10. Subtract this by 2 over 2, right? Because we want to subtract it by its whole 1, right? Subtract it by 1. So negative 1/2 minus 2 over 2 will give us a negative 3/2. Times, we're still not done. Using that chain rule, right? We now have to take the derivative of what is on the inside. So 9x cubed plus 10, the derivative of that would be 27x squared. I'm Now, I'm done taking the derivative of g. Now I just need to simply multiply by what is our f. Our f is a negative 8x. So that will give us times, oopsies, sorry, times a negative 8x. Okay? Now let's combine and multiply some things or make it look a little bit more nice and neater. And as I've always discussed in class, this is our one line of calculus right here. The rest of it is our algebra skills on how we clean up our problem. Okay? So from here, I am going to put my negative 1/2, 9x cubed plus 10 to the negative 1/2 back in the denominator. So I'll write this as negative 8 divided by that 9x cubed plus 10 to the 1/2. Put it back down in the denominator. Over here, I can actually look at multiplying my numbers, right? So what can I look at? I can look at 27 times negative 8, which will give us, I'm not sure. I'm just trying to make sure I do it simplistic to use. 27 times a negative 8, right? Which will give us negative 216. I still need to divide it by this 2 here. So then that'll give us, I believe, 108, right? That gives us a 108. It surely does. Okay? So this will give us a plus 108 cubed, right? Times, well, actually, this is a negative 3/2. So that means it can actually go to our denominator. And we can write it as 9x cubed plus 10 to the 3/2. All right. Now, we have one more piece that we can do. Now we would combine our two terms together, which would mean that we would need to have the same denominator. So if I'm looking at this, this is 9x cubed plus 10 to the 1/2, and this is 9x cubed plus 10 to the 3/2. That means this side is missing 2 of them, right? So I would need to multiply this left-hand side by 9x cubed plus 10 to the 2 over 2. Well, what's 2 over 2, you guys? It's really just 1. So we can multiply that by 9x cubed plus 10, okay? And again, it's technically supposed to be 2 over 2, but really 2 over 2 is just going to give us a plain simple 1. So now we can distribute this negative 8 times 9x cubed plus 10, right? And that's a bad marker for you guys. I'm sure it's horrible to see. So we can look at that and say this will be a negative 72 x cubed, right? Minus an 80 plus, what is else in my numerator now? Plus 108 x cubed all over that LCD. And again, my LCD in this case is this 9x cubed plus 10 to the 3/2. Now, what is next for me to do? Combine my like terms. So what can I combine together? A negative 72 plus a 108 is a positive 36 x cubed, if I'm not mistaken, minus 80. All right. Now, does 36 and 80 have anybody in common? Well, 36 and 80 have at least a 4 in common, so we can factor that out to be 4 times 9x cubed minus 20. And then what was my denominator again? It was 9x cubed plus 10 to the 3 halves. And now we have found our answer. Okay? The next one is very simplistic, but it can be looked upon as something of a bit of a challenge. Now, the question asks us, it says H, or rather, given the table, and let me give you this table, that X is going to be 3, F of X is going to be 1, F prime or derivative of F is going to be -1, G of X is going to be 6, and G prime of X is going to be a -7. And it says, given this information, we want to find H prime of 3, or the derivative, right? Derivative of H evaluating 3, if our H of X is equal to G of X times F of X. Now, it is written in a very a very different way than what we typically see our functions, all right? But not to throw us off, but technically, remember, this is a composition of another function, meaning that if it's a composition of another function, that means we need to use the chain rule. But not only am I going to use the chain rule, but if you also notice, this x times f of x means that we're also going to use the product rule. So if I'm using the chain rule, the first piece that will come is I need to take the derivative of the outside piece of this, right? So the derivative of that would be just g prime, right, of x times f of x. All right? That is the first piece, okay? But now we need to take the derivative of what is on the inside. So this is x times f of x. So that means the f in terms of the product rule is x, and the g in terms of the product rule is f of x. So that would be times the derivative of the first. So what's the derivative of the first? The derivative of x would just be 1. And then we would multiply that by f of x. Plus, we would need to find the derivative of f of x. Well, the derivative of f of x will just be f prime of x times what will be our f, x. Okay? Now, again, it just looks a little crazy as we have it written out as such, but I guess I can clean it up just one little extra piece and say that h prime of x would equal to g prime times x times f of x, right? Times f of x, right? Plus x times f prime of x. Okay? Now, what we have been called to do is to evaluate it at 3, right? So I'm saying h prime of 3 equals to g prime, right, of 3 times f of 3, right, times f of 3, right, plus 3 times f prime of 3. Okay? Now, we need to use our table. Our table is saying that if we have f of 3, that is going to equal to 1. Okay? If we have f prime of 3, that is going to equal to -1. If we have g prime of 3, in the wrong spot. If we have g prime of 3, then that is going to equal to -7. All right? So now let's plug it in terms of what we see. So G prime of 3, right? So that means G prime of this right here would just equal to a -7, right? Times, what's in my parentheses here? F prime of 3. So F prime of 3 would just be 1 plus 3 times F prime of 3 is -1. So that'd be times -1. So -7 times 3 plus, well, this should be a 3 minus 3, which would give us a -2, right? And -2 times -7 will give us a +14. So when we're using these tables, don't get convoluted by what's the extra extremities are, right? You just want to look at actually just the facts of the table and the facts of the product rule or quotient rule, possibly. All right. I think that will conclude my video for today on chain rule. And that's it. Peace.